Now let's review how to determine the sample size needed for a desired margin of error and confidence level. So here are formulas. We have two of them. One is for proportions. So we would take z critical divided by the error and square that and then multiply it by the probability of success times the probability of failure. And then I stated down here as a reminder, if you don't know what the value of P is, which is our preliminary value, then you want to use 0.5 if you don't know it, which means Q would also be 0.5 because Q and P are complements and have to add to 1. When you're trying to find a confidence interval for a mean and you want to find the sample size, you want to use this formula, which is z critical times the standard deviation divided by the error, and you take all that and square it. And then no matter which formula you use, you always want to round up to the next whole number. So our z criticals, that's our z-scores for the desired confidence level. Our Q is the complement of P, things to remember. Sigma is the population standard deviation, and E is the error. And I put down here in a note, just as a reminder, always round up to the next whole number when n is calculated between two integers. Okay, let's look at example 7 and 8. A health organization wants to estimate the proportion of adults in a city who have received a flu vaccine this year. A preliminary study suggested that approximately 62% of adults have been vaccinated. The organization wants the estimate to be within 5 percentage points of the true population proportion with a 95% confidence. What is the minimum sample size needed to estimate the true proportion of vaccinated adults with the desired margin of error and confidence level? So let's pick out all the major information. We want to estimate our proportion, so that tells us which formula we're going to use. We're talking about proportions. We have a preliminary study where the probability of success is 62%. So that tells us our value of P, so we don't have to estimate it at 0.5. We want the estimate to be within 5 percentage points, meaning the error is going to be 0.05, and our confidence level is going to be 95%. So let's write all this down. We have our preliminary proportion is 62% or 0.62. Our confidence level is 0.95. Our error is 0.05. And even though it doesn't tell us, we know that our Q is going to be 0.38 because it's the complement of 0.62. Here's our formula. We have n is equal to z critical over the error, all squared, times the probability of success times the probability of failure. Now, the only thing left to find is z critical. Go ahead and pause the video for a minute and use GeoGebra to find your z critical to practice. Your z critical is 1.96. So let's put all that information in here. So we have 1.96 divided by the error, which is 0.05. Then we're going to multiply that by 0.62 and then again by 0.38. When we work that out, we get 362.032384. So our final answer would be that we need 363 adults in the sample. Okay, looking at example 8, We have a car dealership that wants to estimate the average number of cars sold per month. Previous data indicates that the standard deviation of monthly sales is 15 cars. The dealership wants to be 95% confident that their estimate is within a margin of error of 3 cars. Find the sample size needed. So let's look at all the important information. We're estimating the average, so we're going to use the other formula. We have a standard deviation of sigma is equal to 15. We want to be 95% confident, and our error is 3. So the formula that we're going to use, because we're doing the mean or the average, is this: z critical times sigma divided by the error all squared. We're given that sigma is 15, the error is 3, and we need to find our z critical. But the nice thing about this is in the previous example, we also did a 95% confidence level. So our z critical is going to be the same. It's going to be 1.96. So that saves us a little bit of work. So let's put all of that information into our formula. We have 1.96 times 15 divided by 3, and we're going to square all of that. When we do that, we get 96.04. So when we round up to the next whole number, we're going to get 97. So we would say we would need 97 cars in the sample.